morning, Math 8 students. Okay, we're at systems, right? Systems of equations, something we've already looked at, but we've looked at solving them graphically, right? We've done a little bit of algebra as well, or algebraically, but we're going to take a look at solving systems algebraically today, not graphically, okay? So when we solve them graphically, we're solving we're graphing two lines, and we're looking to where they intersect or where they meet. Just a quick review, right? We have two lines here. The equation of a line is mx plus b, right? Our slope is our m, that's our slope. And our starting point, our beginning point, our initial value, as we also know as our y-intercept, is our b value. Okay, so some algebra stuff here. We have two equations over here. Both of these equations are set equal to, okay, you set it to yourself. Yes, they're set equal to y. When they're set equal to y, that means we can set them equal to each other, right? So y equals 3x plus 4, and then y equals 8x plus 4, okay? So in order to get our point of intersection algebraically, we set both of these equal to each other, and we solve them, or we solve it, for x, and then we figure out what our y is. So basically all we're doing is solving an equation with variables on opposite sides. So what we're going to do is we're going to set this up. We're going to put 3x plus 4 equals 8x plus 4. Okay, first step, we always draw our line, right? Your DCV SADME guide sheet shows you that. Okay, so we draw our line, we look at this. Do we have distributive property? In other words, do we have parentheses where we need to multiply? We do not. Do we have like terms on either side? Nope, we do not. 8x cannot be combined with 4, and 3x cannot be combined with 4. Those are separate. They're not like terms. They cannot hang out with each other. So what we're going to do, the first thing we're going to do is we're going to combine these variable terms because they're on opposite sides. So I can combine either one. I can move the 8x or I can move the 3x. But in this case, I'm going to move the 3x, and I can do that through inverse operations. I have a positive 3x, so the only way to move it is to do the inverse, which is a negative 3x. So what I do on one side, I got to do on the other. This makes a zero pair. They disappear. And you notice I'm writing everything down. My equation is going to start to get smaller. What's 8x minus 3x? Well, that's 5x. And then we bring down our 4 as well. Now we're at a simple two-step equation, right? We're in inverse operations. We're looking at our constant term. And if, the light bulb's going off in your head. The 4 is the constant term, so we're going to subtract the 4 because it's already positive, right? These cancel out, and then we have 5x equals 0, right? So now we have multiplication, right? What's the opposite of multiplication? The opposite of multiplication is division. We do this, we actually see that x equals 0. We're not done though. We do not have a point of intersection. We have the x value. So how do we get the y value? Well, oh, yep, that's right. Yeah, Mr. Frechette, we use one of the equations above. Well, I'm going to use y equals 3x plus 4. Now, I know my x value. My x value is 0. So I'm going to go y equals 3 times 0 plus 4. Now, y is going to equal, what's 3 times 0? Well, it's 0 plus 4, right? Our y is equal to 4. What is our point of intersection? Our point of intersection is actually 0, 4. And if you're looking at this, you're saying to yourself, oh my goodness, Mr. Frechette, the point of intersection is the y-intercept. That's where both of these graphs begin, right? Because it's 0, 4. I see an x value that's 0, so that means it's 4, right? So the point of intersection here is 0, 4. This is also known as your y-intercept, your beginning, your initial value. This is solving systems of equations algebraically when they are set equal to something. Like in this case, it was set equal to y. So that's why we were able to set them equal to each other. Okay, so stay tuned because we have what is called substitution and elimination, which are two other methods you can use to solve systems algebraically. Well, hang in there, everybody. It's snowy out. It's a snowy Friday, but we're almost at February break. We will see you in class this morning, rocking and a rolling and ready to do some math. Have a great morning.